Guys, welcome back and let's continue with the next part. So today's guys, again, we'll continue with the load balancers, right? But today the concept is very important, right? The yesterday motto was to explain you the use case or the main use case of the load balancers, right? I think I explained you the concept, what is front end, port number, backend, reverse proxy, what is load balancer, and plus we also use and configure one classical load balancer in my yesterday class, right? But actually, load balancer nowadays can do much more things, much more capabilities they have. Okay, and let me explain you some of the capabilities that is very, very much useful in the real world. Okay, so let me set one context here. For example, let me take the example of google.com. Okay, so if you type www.google.com, okay, this is the one domain name we have or DNS name we have. Okay, and when you type this or you type slash, same thing. So technically, if you type this, you will be landed to the Google website. Okay, let's go Google search engine, or maybe I can use the word called Google search engine or search app you connected. But if you type www.google.com/mail, okay, if you type this, then you will land it to a different app, and that is called mailing app of the Google. And similarly, if you type slash maybe calendar, maybe you type slash people, Google has different apps. Accordingly, you will connect to this particular app. Okay, for example, if I type here www.google.com, google.com or slash, maybe you can write, you will be landed to this Google search app. But in the same URL, if you type slash mail.com, then you will be landed to the Google mailing app. That is, you guys know, that is that is actually gmail.com. Okay, so I stop this, but that's what you will end it. Okay, so now what I'm trying to tell you here is, it means your domain name is same, or maybe let's say your IP address is same, or host name is same. In the host name, your path, okay, decide where my client will land. They will land to search app or the mailing app. Okay, so in the URL, okay, this is the URL we have. In the URL, your path will decide where you will reach, you will be landed. So you will landed to the search app if your path is slash, or you landed to the mailing app or Gmail in our case if the path is slash mail. Okay, but whichever app you landed, okay, that app is actually known as, or that area or that path is actually known as endpoint. It means your slash mail decide your endpoint would be mail app. Your slash decide, or sometimes slash search also. If you type slash search also, that is also the same thing. If you type slash search, you will land it to the same app. It means slash you write or slash search you write the same thing. Slash search path will decide your endpoint to be search app. Or I can use one more term here. Okay, this particular path will decide where you will reach, where you will route it to. So that is a reason this path is something also known as route. So either you can use the word path or route, it is almost the same thing. Okay, this one. Now, so finally, the summary of this discussion is, right, in the URL, your path decide where and which app you connected. Okay, this one thing. Next thing, guys, this is one information I want to give you, because I'm going to use this information somewhere in the today's topic that's called load balancers, okay, in AWS class. But I want to tell you one more thing. Okay, before this, before the topic I'm going to start, topic would be ELB only, and in that ELB I'm going to start a very, very important topic that we use a lot in the real world. It's called ALB, application load balancer. Okay, so before I start the topic called application load balancer, okay, what I'm doing here, I'm just giving you some basic concept. So this concept I can use very quickly in ALB topic. Okay, one more small concept I want to explain you. If you guys know about OSI layer in networking world. So we have total 7 layers we have. Okay, so the last layer, that's called layer number 1, is known as physical layer. You guys might know. Layer 2 is known as data link layer. Layer 3 or L3 known as network layer. Layer 4 is known as kind of transport layer, right, or protocol layer. Layer 5 is is your session layer. Layer 6 is your presentation layer, or vice versa, just check the numbers, right? And 7 is your application layer. Okay, the main thing that I want to tell you here is all the decision of the IP addresses. Okay, it means if A computer want to connect to B, and as IP of B is 100, IP of A is 200. So A will create a packet, okay, and send to B. In the packet, they will type the source IP and the destination IP, and B will go and check the source IP and the destination IP. All those things will actually happening at the layer number 3 in networking world. Even though if you have some router in between, okay, router is the one who will check the destination IP address and send that packet to the destination and help you to send this packet to that particular network. Okay, so router always check the the IP addresses. So that is the reason we always say that router is the one who work on network layer number 3, because router is always check the network addresses. Is in our case is IP address, IP4, IP6, whatever the address you have. Okay, there's one thing. But after your packet reach to computer B, in one computer B, you might be running with mail server with port number, let's say 25, you're running web server in port number 80, multiple app is running by chance, for example, here. Okay, how B come to know the packet what come to B belongs to mail server or the web server? So in the packet, we have the port number. So port number is a decide your packet come for this particular applications. Okay, so port number guys normally work at the layer number 4. This is called transport layer. Okay, so it means any protocol specific thing, core protocol specific thing means either number come for 25, 80, or you might have running with DNS server that run the port number, I think 53. Okay, so so any of the decision that what kind of packets come, right, which port number they come, and which kind of network connections we have created, reliable or non-reliable, like TCP or UDP, and some more kind of we have, right, is done at the layer 4. Okay, and layer 7 guys, I'm just only giving those points that is relevant to our today's topic. This is not the pure networking classes, and there's no meaning to discuss OSI layer and further discussion about this, but layer 7 is very important here in this. Okay, let's say you're sending the packet from A to B. The way you send the packet, the way you create the packet. Okay, so in the packet, we have an IP address of source and destination. Okay, we have the port number of source and destination. Okay, plus we have a data. Okay, that what data want to send, maybe login and password, chat message, email, whatever it would be. But with the data, you have to send some instructions. Okay, means how you going to use this data. So I'm sending some data. okay, data. So the way you send the data, right? So in B, for example, let's say B is the web server. Okay, in web server we have multiple different pages or programs. Let's say program number 1, page number 2, web page number 3, web app number 4. Okay, so where this data go, which page gonna use it, how they gonna use it, how we're going to insert, and tons more things, okay, about this information will go uh, in the kind of way, that way is called headers. And they are normally known as applications header, because finally your data is going to this program is known as applications, and this application, how they consume the data, which application, which program going to consume it, how they're going to consume this data or use this data. Or maybe you sometimes have to send the instructions also. So what instruction you have to send to this program, it always goes in the application header that come here. Okay, and every kind of server has their own way of sending the instructions. They are normally known as protocols. Okay, so in the web server, the protocol may be HTTP. In mailing, the protocol may be SMTP or POP, and for all the things, right? And for file transfer, protocol may be FTP, SFTP, tons more protocols we have. So every protocol has some way of sending the header, and through the header, they're sending the instruction, something like this. Okay, so there's a layer, 7 layers we have. Okay, right now, guys, if you have any device, okay, or maybe you have any kind of maybe server, maybe for example, okay, if any device or any server, if they work on networking, they understand networking, and in the networking, if they only work only in IP addresses, they only deal with IP addresses. And according to IP address, they will check and they will take some decisions. For example, router is the one example. The router has no such concern about your port numbers. Mostly, they only deal with the IP address and the network range and something like this. Okay, so we can say router is a work on layer 3. Okay, so guys, yesterday we had used a load balancer. There's a classic load balancer. Okay, and those classic load balancer guys work on IP addresses, and at the same time they also understand the port number also. You know what we have created yesterday? We created one sorry, one load balancer and say anybody who come on port number 8080, okay, we will send to backend system port number 80. It means this load balancer was classical load balancer, and this load balancer has the capability to read the port number also from the packet. Okay, so I can say my classical load balancer is example of layer 4 transport layer, because they understand the port number also. Okay, you don't say the word because they understand IP address also. So if somebody understands IP address also and the port number also, so always give the bigger name, the upper name. Okay, so anybody who understand port number, they also understand IP address, they also understand data link or physical layer also. So that is how we normally see. Okay, in the networking world. So classical load balancer is our load balancer that work on the port number. They understand the port number, they understand the protocol TCP UDP. Okay, that's all. So I can say my classical load balancer is a layer 4 load balancer or transport layer load balancer. That's all. But my classical load balancer doesn't understand anything about my application internal protocol information like headers or like instructions. Okay, they don't understand. For example, if I type something like this, my URL http / my server IP or my load balancer IP maybe, then I write the port number, then I type the path, that is also known as route sometimes. Okay, so if I ask my classical load balancer, do you understand this name? Yes. Do you understand the port number? Yes. On the port number, basis, can you take some decisions? They can say yes. If anybody come on this port number, I will send to this port number. I understand this. Okay, it means they understand till layer 4. Where if I ask, can you understand this one also? Can you take this part, or can you take this particular information from this URL, and based on this information, can you take some decisions? Answer is no. They say no, I don't understand this. Okay, because I only know till port number. But in the URL, URL look like this, but this information in the URL behind the scene go inside the header. And header is a part of the protocol, and protocol is a part of the application layer. There's layer 7. So typically they say I don't know layer 7. Even though if I go and search in the Google, okay, let's say I'm searching my name, Vimal Daga. Okay, Vimal Daga, right? So this information, guys, go to Google, this particular app, and my information of Vimal Daga. Let me correct my name. Okay, go in this particular URL. Okay, you guys might know. Okay, any information or data go in the URL. Okay, so this is the data. Vimal Daga, go in the URL, and data always go with some kind of variable. So Q is the variable here. Okay, and this data will insert in this particular program. It's called one app running in the Google is called search app, not in the mailing program. Okay, because we search here. Okay, so in this case, any data that go in any program in the URL, then they are known as query string. So this is the query string we have. So with the help of query string, we are sending the information what we are searching in the Google. Okay, to the Google system and into the respective app. Okay, but this information, guys, is also goes into the application header, means HTTP header. Okay, so these are a few examples. Otherwise, there's lots more information, guys, go inside the HTTP header. Okay, and any devices or any program that has the capability to open your application header or protocol details, okay, they can read the information, and after they read, why won't they read? Because I want after they read, they will do some decisions on it. We can get some condition and say, if this is happening, then do this. If this is happening, this is coming, then do this, or on those things. Okay, so any device and program who have capability to read the application header, we can do something and create some decision depending upon what data is coming in the application header. Maybe they're coming in the as a path, as this called path or the route. Okay, or they're coming here over here in the query string. That's normally mostly known as, guys, in HTML, it's called method get. Or they're going inside the header that's not visible. Okay, it's called post header or post method of form, or they were much more kind of thing may be possible. But everything is a part of application header. So this information that I am giving to you, why? Because all this information will help you in my next topic called ALB. But if you ask CLB, do you understand application header? No. So any data coming in the application or header, your CLB won't able to read it. So we can't use CLB to do some decision based on the headers or based upon the application data. CLB is restricted to the transport layer protocol, layer 4. But if you have a requirement, something like this, the way I started today. Okay, what my requirement is, if my URL contains /search, so I need a load balancer that will read this data or my data from application header, and based on this, they will send me to a different endpoint that's called search app. Okay, so plus I need one more load balancer from my URL. Okay, they will read this data, and based on this data, they take the decision and send me to different endpoint that's called mail app. So you will have one single load balancer running in this particular IP address. So one single load balancer and same name, same IP address we have. So one single load balancer Okay, any client come and hit to this load balancer. Okay, either they type this URL or this URL. Okay, in both the URL, the IP is www.google.com. So this will be the load balancer IP address. But this load balancer has a capability. In this load balancer, we had created a rule, and rule would be if somebody come in /search. So load balancer says now I know application header to read because I'm the application layer level load balancer. I know how to read this, and based on this, you guys have created a rule on me, and the rule would be anybody come in this search, send me to this app. Anybody come in /mail, send to this app. Okay, a rule may be something like this. Anybody try to search Vimal Daga in the query string, send to the other system. Okay, everything, or somebody come in this particular URL with some kind of malicious something like this URL. In this case, don't connect to any app, send to some error document and stop them, block them, something like this. Okay, all this can be possible if your program or device, or in our case, the load balancer, has a capability to support the application header data to read. And after they can read, we can get a rule on it, and according to rule, we can do much more. Okay, so Google, guys, is a great example of application load balancer. So when you type google.com, behind the scene, this is just a DNS name, but behind the scene, you connect to the application load balancer. That is a reason, okay, they will detect the path, and accordingly, they will connect you to the respective apps. And almost same we are going to develop today. And for this, there's one more different kind of load balancer available in AWS. Okay, one we had created classical, that was one we created yesterday. Okay, I'm going to create one more today, that will be application load balancer. Okay, and they have the application load balancer, they understand the protocol HTTP or HTTPS, and based on this we can do multiple different capabilities. So they understand the application inter feature of HTTP and HTTPS traffic. Okay, and they can do a lot of routings and do much more things. It's very, very powerful load balancer. Tons of things we can plan by this. Okay, almost all the use cases we use ALB a lot. Okay, that is one of the reasons. Whatever capability you have in CLB, like I told you guys, anybody who understand application layer, it means they understand all the below layers. Okay, so if you whatever guys you do in the CLB, based on the port number, do something, based on IP, do something. Same thing ALB can also do for you. That is the reason why CLB we don't require, and that's what become previous generation, and they're going to do stop the services very soon. Okay, this is what. So today I'm going to start with ALB, then we move to NLB, then GLB. Okay, but ALB is very, very important and very interesting. So let me explain this concept in very detail. So I think I still here you got some idea. Okay, ALB is application layer application based load balancer or application load balancer. So let's say, let me take the same example of google.com. Let's say some client, and guys, this is what I'm going to show you today. Let's say some client type google.com, and by the help of DNS, they get the IP address, and finally they hit to the load balancer. Okay, and this is the application load balancer. Okay, load balancer, and name will be, let's say, www.google.com. Okay, that's what they hit. Now, what Google has planned, they have a different team. Every team has a different responsibility. One different team they have for search. Okay, so they have created one search app, and they launch this one search app in one of the instances. Okay, so in this instance is running with the search app. Okay, so let me write. So /search is running here. One more instance they're running this instance with the different instance with different app altogether, name, let's say, /mail. So that is running over here. But they know, Okay, in search, there's a huge client gonna come up. One single instance won't able to handle this, so they might launch some more instances, same copy with search app. Okay, more. Same thing, the huge request come in the Gmail, so they launch one more exact copy for the mail, for mail or Gmail, like this. So like this, depending upon how much requests they come up. So we have hundreds and thousands of server running for search, 100,000 server running for mail. Okay, managed by different team altogether. And maybe this team have no search team. Let's say ST has no relation with MT mail team. Okay, individual team they have, right? But why they launch a lot of, because a lot of traffic is gonna come up. So what we want, when the first client come, they hit to this search app, second client come, they hit to this app, then this one. Again, here I want some load balancing. That's what my requirement is. Same thing is when anybody come to mail, I want somebody connect here, here, and there. It's called load balancing. I want the load balancing also over here. Okay, over here. So in this case, if any client come to my instance, let's search. Okay, let me give the name called A here, and B here, and C and D. So anybody try to connect with A. Okay, so A would be my final target for the customer. Okay, my final target for customer is not this load balancer and not this load balancer. My final target for the customer would be A load or A system, or maybe B system. Okay, so what can we do? We can create one group of similar computers or similar systems. Okay, and that group is called target group. Okay, what is the benefit of target group? If you create a target group, automatically behind the scene, Amazon will manage a load balancing for you. You don't have to create any extra load balancer like CLB, what we had discussed yesterday. Automatically, okay, your load will manage in this system. Now onwards, you don't have to connect any instant directly to the load balancers. Okay, you say I want to send my traffic to the target group. Okay, but if you send traffic to the target group internally, right, target group work as a typical load balancer. Automatically traffic first send here, then send here, then send here, then send here. Okay, this is the bytecode behavior of the target group. Same thing, these two system I want, because they're same copy, and obviously the reason is I want to do a load balancing. So automatically what I do, I will create one target group. Let's say this target group is called mail target group, and this is a target group called search target group. So automatically any traffic come here, by default you don't want to manage this. By default they will do a load balancing for you. This is how AWS created in the AWS, when you create a target group, how to create, show you, they will behave like this. Okay, so now this is more look like CLB, what we had created yesterday, but it's not CLB. It has been completely internally done and managed by AWS. Right, it's more like look like CLB. Okay, but here now we have two different teams. The company is one single, Google, right? So there's no meaning to tell somebody that if you want to come to search, then come to www.search.com. Want to come on mail, type www.mail.com. It's not a standard name, right? To make the company standard name, they given a one single name called www.com. And this name, they make it popular to entire world. And they say, if anybody want to come to Google, type this name. But because in the Google, we have multiple app. Okay, multiple app they have. Okay, so what you can do, okay, to differentiate which app you want to connect. So if you type slash, after slash some name, okay, if you type slash mail, it means by this name we understood which app you want to connect. So in this case, behind the scene, the duty of ALB come in play. Because ALB has a capability to read the URL or query string or the headers or the application data. So in ALB, we'll get the rule that if anybody want to come to this URL, I will send to this endpoint. Anybody come to slash search URL, I will route to this endpoint. So your name will help us to decide which route you want to go. That is, guys, these names are known as routes. or routing path something. Okay, to this endpoint. In this case, you don't have to tell that I'm CND. We say I will send to this target group. Now inside the target, you have one computer, two or more, hundreds of millions. The team will handle. If the team think in the mail there's a huge load column come up, they might launch thousands of mail server by the ones in the target group. And any packet come to slash mail, they send to this target group, and inside the target group, they automatically do the further load balances. Okay, and this is how it works. And this is the very typical setup, very powerful setup. Almost we go to Facebook, Google, everybody almost use the same setup. Okay, so guys, whatever say www.google.com, that is you're not actually connecting to the google.com. Actually, you are connecting to the Google DNS, not the DNS. After DNS, you will connect to Google application load balancer. So whatever load balancer they are using, that is a different point. But they're using for some kind of devices, because device also available in the market for the load balancer, like F5 devices, all the things. But you are actually connecting to the actual load balancers. And these load balancers are mostly application load balancer. Depend upon company. If they have multiple app, they mostly use application load balancer, and then they'll send to respective target groups. Okay, that's how it will work. Okay, so let me guys show you this demo how we can do. But this is the rule, and rule can be based on your path. Let's go routing path, based on query, based on some other HTTP respective headers. So there's a lot of things in the HTTP header available. So if you know about HTTP header, HTTP web services, or HTTP internet methods, okay, grammar, verbs, okay. So almost you can use anything here to take the decisions, okay, while creating the rule. So rule is the one who take the decision where to send. And it is not only they are sending to target groups only. Target group, inside the target group, we have the instances, right? Instances. So they're not only sending to the instances, even though ALB has a capability, right, to send this traffic or route this traffic to your own premises computer also. So maybe your computer running in on premises, they can send the traffic here also. In some cases, if you want. Okay, in some cases, guys, they can send the traffic to your container platform, like Docker, like Kubernetes, like OpenShift, and whatever the container platform they have. Typically, they are running the microservices. Okay, because in the microservices, okay, we have to do lots of load balancings in the microservices. One service then to other services, and between the services we have the load balancers, and load balancer has a capability, should have a capability to understand the HTTP header, especially the REST API endpoints. Okay, so in the microservices, if my load balancer doesn't understand the REST API endpoints, where it is REST API means where they have the HTTP header that contains some grammar, get, post, put, something like this, then it won't work, right? So in the microservice world, it is again, this is the great use case. Microservice is the great use case for your application level load balancers, right? Otherwise, there will be much more use case on it. But here in that case, I'm going to show you this demonstration in AWS Cloud with the instances. Okay, how to load balances with the different target groups. Okay, but if you see here in this example, I mean, they might show you this is through microservices, container, and much more things that support. Okay, so let's guys, I believe you understood the points and some terminology what we need. But for the application load balancer, the minimum requirement would be you need a target group. They're gonna ask you. Okay, let me show you how and when. So let me show you step by step how it works. Okay. So click on the create. Okay, they ask you about the application load balancer. Before this, let's do one thing. Let's launch multiple instances so I can show you the demo. I'm going to launch 4 instances, guys, in total to demonstrate this. Okay, 4 total instances I'm going to launch. So even the same thing, guys, you can idea is same. You can use in the private world also, the way I show you for better practice and management. Okay, to this instances. So some instance already running, guys, my web server in 1 and 1B in my private world. Let me launch two more. So I'm going to launch, there it is, two more with same AMIs, and I'm launching that too. Okay, I'll change some data there, and this will be launched in my VPC and in my private world. I'm putting in private A. Okay, and this is, let's say this will be my mail OS server, private. Okay, I'm guys enabling all traffic right now and launch. Okay, so this two instance, guys, we already had yesterday. My web, I will change something there to have this kind of look and feel. And this two instance I launch right now to set up a mail kind of. Obviously, I'm not going to set up a mail server, but I'll put some static data that look like it is a mail server. Okay, so 4 instances we have. Okay, and to connect this instance, because they are private instances, I will use this basin host to connect with EC2 user, EC2 user. And what I'm doing right now, from this instance, I'm logging to my instance, first one. Let me go here to my first one, to my private one, A. This is a private IP address. And what I'm doing, so I change something there. And let me check the security group. I might change some security group yesterday. I don't know. So in the security group, actually they allow only for HTTP. Let me delete this and add the rule just for a while for all traffic. So we have a connectivity. So it will be connected. Now what I'm going to do, I'm just going to my first login to root account. And in this system, I am going to create a folder called source, that's all. So if you create a folder here in this page, then it become your search app. Typically, this is one of the way. Otherwise, normally, if you guys know REST API development or full stack development or web application development, recently I started this course. If you guys want to join with MERN, so 7 o'clock I started yesterday only. So we can create our own app. That's a different point. But here, I'm just creating a normal page index.html, and I'm just typing I am search Google. Okay, and computer number A. That's all. Right here. And to check everything is working fine, I just log out from here. Okay, and from here, and now if you curl this page from other computer, so this curl, if you do /search, okay, they are showing movie permanent, but if you search in this way, you get the output. Okay, so output is coming properly. Nice. So first setup has been done. Let me do the same setup very quickly in other computers also. So the computer number, whatever name would be, has been done. And the same setup I'm doing in web private number B. I'm also using this system as a web server. So log in with a root account, creating a directory where HTML search, and in this directory I'm putting that I am search B. Okay, page name index.html. That's all. Okay, this is the computer number B setup, and if I try to do a curl just for quickly check, just for quick testing, that here my search app with slash it's working fine. So my this two computer has been set up. Let's say this two app is already running, has been set up. I'm doing same setup for mail also. And for mailing, I am using this OS having this private IP address. Okay. I'm doing manually, but here you guys can use automation tool like Ansible, something like this to configure these things. Okay, so echo I am mail A means first computer. Okay, index.html. So this has been set up, and I would like to check, because if it's not working properly, then your load balancer won't work. So it's very harder to sometimes check where the issue we have. So web server is working fine. That's what we get tested. And last, same way I'm going to configure this system. So this will be same SSH, and I'll do sudo mk dir where HTML mail echo I am mail B. That's all. So all the four web server, or I can say the app server, has been configured. Okay, now how we can use the ALB load balancer here to do the things, right? So these two parts also been set up. Now these two systems working in a different team, let's say. So I would like to first create two different target groups. Okay, how? So in the EC2 page, in the load balancer, guys, we have an option called target groups. So I'm going to configure load balancer right now. I am first setting the target groups. So I don't have any target group right now. How we can set the target group? Let me show you how we can set the target group. To setting up the target group, okay, we can go and create the target group from here. Okay, target group from here. And here, guys, they're asking you, okay, where is your target group? Okay, means they're asking, guys, for hold for a second, please. So they're saying you want to do technically what we are creating. Right now, I'm not configuring ALB. We'll do after some time. I'm only configuring this target group that is work like a load balancer. So they're asking you're doing the load balancer or target group for the target computer or the instances, or for the instances in your VPC, especially EC2. Okay, or you want to do a target group with your on-premises computers. Just give the IP address to them. Or there's one topic guys going to come in the future class called Lambda. We can use target group with Lambda functions also. Lambda is a serverless service. We can directly deploy our programs there, function there to run. Okay, so anybody come to a load balancer, they will automatically hit to Lambda function, and they will run the Lambda function and run the Lambda function and give the output back to the client. Or you can add further application load balancers. Okay, there's a possibility we can add in the target group some more load balancer also. They will further balance the load. So that can also be possible. Means load balancer inside load balancer. Okay, because normally target group we got to use the ALB. Okay, so under ALB we have more ALB in some use cases. Okay, So what you want, in my case, I would like to do, I want to create a target group for my instances. Okay. How will do? Guys, can you hold for a second, please? Okay, so in my case, we are creating a target group that is like load balancing between the instances in your specific VPC. In Mumbai VPC, we can specify. So I'm going for by default setting, guys. The target group name, let's say this is the target group for my search. Okay, so this is a target group I'm creating for the search instances. Okay. Okay, now you have to write your protocol name. So right now, guys, my instances in the target group, because like a load balancer only, guys. So you have to tell in this search which port number they are running on and which protocol they are running on. They are running on HTTP, but HTTP, guys, is a protocol application layer work on a TCP concept. So actual protocol is TCP, reliable protocol. Okay, so that's what the port number work on a protocol called TCP. You can write HTTP also, but it will be same. Maybe you can write HTTP. That's also work the same. Okay, so let me use HTTP only. So my application layer protocol is HTTP, work on a port number called 80. Which VPC or instance is running right now? Okay. So in my case, this is the VPC we have. And if you are using HTTP, HTTP has a multiple different versions, HTTP 1, 1.1, HTTP 2 also we have. So mostly in real world, we use HTTP 1.1. That's the most common version available every time. Okay. So I'm using HTTP protocol version 1 or 1.1 also support here. Okay. Health checks, you guys know. So behind the scene, guys, they will work like a load balancer who target group. So they keep on checking the health of your instances. So for the health check path, you can use / or because we already have this path / mail available or / search available. So that's also can be possible. Okay. So I'm checking the health in / search /. Okay, or maybe you can give the file name also, index, that is also the right, but you can write / also, because in the website by default, if you write / they treat this, it is like index.html page. Okay, so whichever page name you want to check for the health, what is health, we discussed already yesterday class, you can type here. Advanced health settings, it will be same thing what we discussed here. Okay, we're sending the health on the port number. This is the threshold, all right. So healthy threshold, let me check for 2 times. After 2 times, they connect. This become healthy. And then there's again 2, timeout, maybe let's say 4, interval, let's say after 5 seconds, I will keep on checking. And if my web server send a request connectivity, guys, and when you guys connect up with a page, we get a status code 200 when successful connected. And if you don't connect, if page is not available, then 404 error come up, page not found. So there's a multiple different code in HTTP protocol. 200 means successfully connected. Okay, that's what we want. So, for example, even though you guys know, but if you connect, right? Not this one. What are the IP would be? So behind the scene, guys, the output come up, but behind the scene, you will get a success code. Okay, you can use the I option, the call command. Okay, you will see the success code 200. And you can also see when you connect with any protocol, mostly they use HTTP 1.1 protocol. And these are some of the few HTTP headers. It's not visible, but it's run behind the scene. So we can use I options to see the header that's sent to and come from this particular server to the client. Okay, so that's what I'm using here. If you're successfully connected, then 200 messages trail to the server or the load balancer or target group that is successfully connected. Or tag, you guys know tags we don't require right now. Okay. Hyphen underscore doesn't work, so let me use target group search. Next. Now these are the lists, guys, come up in this target group, which all target you want to register, which all instances you want to register. So according to our plan, I want to register this web one and this web one. Okay, and both web one guys are working on a protocol called TCP on this particular port number. Okay, so we defined here the port number for this. Initially, guys, last page, we defined the port number 80 for my load balancer, but here this is the port number for my instances. Okay, I want to include, right now, I don't have any instance. Here in my target is 0, but if I include, then these two will be included in this target group. Okay, so technically one target group has been created that has 2 instances. And you want to create this target group? I say yes, that's all. Your one target group has been created. Okay, created. If you click on the target group, you can say anybody come in this target group with this protocol on port number 80. Anybody come on this target group that is also like a load balancer on port number 80 with S3 protocol. In this case, okay, in this case, they connected to any of these 2 targets, this one or this one. Okay, this one or this one. They connect to any of the instances. Right now, if you see instance is unused, it's still unused, and your target group is not associated. Because target group is a way to manage. Technically, it will do load balancing for you, but you have to use the target group, and target group is mostly used by your application load balancers. Other load balancers also can use, but mostly they use by ALB. Okay, so till the time you connect with the ALB, or till the time you connect this target group with your load balancers, okay, instance, this option doesn't come up here, it will be non-associated, you will see, or your instance will be unused. So we'll guys connect this target group in the ALB soon. But let me create one more target group called target group mail. Same way. So I'm going to create one more target group exactly the same way. It's for instances, and target group is for mail. This target group, anybody come on HTTP protocol with 8 port number 80. Then this is the VPC we have, same protocol, health check is same, and here they will check with the /mail because I'm going to connect the mail server. Mail is working, let's say, in the mail. This part, health checking, maybe threshold 2 we check, timeout, let me check 4. These concepts I explained already in very detail my yesterday class. Okay, since everything is same. Okay, and I'm going to connect 2 mail server in this target group. Okay, on port number 80. So anybody come on this mail server port number 80 or whatever port number they would be, they will be do the load balancer in this target group. Okay, include and finally create. So based on the plan, these are the 2 target group guys we have created. Even this target group is using 2 instances, but 2 is unused because this target group is not associated with any of the load balancers. So this part is done. The final part is, that is pretty simple, is to create the application load balancer. Only thing in the application load balancer that is very unique is the creating this rule. So we have to create the rule there. Okay. So let's go and create the load balancer. So now we have 2 target groups, this one and second. And in the load balancer, I have one that was we had created yesterday, CLB, classic load balancer. But I'm going to create one more load balancer for ALB, right? So how to connect? So for this, let me use this one. Even though this guy's option called migrate. So the older classical load balancer can be migrated to newer one. It's called ALB. Okay, it's called application load balancer. If you want to migrate the older, that's the option they have. But let me create a new one. So it's called create load balancer, application load balancer we have. Okay, and guys, that's what they're talking about. The ALB can be connected to Lambda, can be connected to instances, all things I explained to you. But let me create here the application load balancer. This is called my application load balancer for web and for mail. Okay, that's what I connected. This also I explained to you. You want your load balancer to be public facing or internal facing. So let me connect with public facing, so anybody publicly can connect. If you want public facing, you need to put in the public subnet. That also I explained to you. Your IP work on IP4, IP4 and 6 both. That's what be your choice. Let me go for IP4. Okay. And network mapping, you guys know this is a VPC. So my load balancer is going to put in this VPC. Okay, in this VPC we have two different AGs we have in this VPC. So if you want to recommend your application load balancer, we will do a high availability. Then put this application load balancer in both the AGs, so that you internally AWS will put ALB in two different AGs together, so to give the high availability. Okay, if one of the AG goes down, they will internally connect to the next ALB. So internally, this diagram won't be like one ALB. Internally, let's say the client is here and we have the client. Now they have two ALB. One is running in 1A, one is running in 1B. Okay, this will have a different IP address, this will have a different IP address. So how client will do the load balancing? So between this, they will use the DNS always. So client always carry DNS. DNS will convert this name into this IP first time, same name into this IP next time. So DNS will do the further load balancing. I will talk a little bit more about in my upcoming DNS class. This got out 53. Okay, so that's what DNS will do. But here in this AG, you have subnet 1. Okay, this is subnet we are using here. Okay, and in this VPC, this VPC actually was wrong. We had created, I think, this VPC actually. So in this VPC, okay, this I'm using, and this VPC I used to create two subnet. Okay, if you can't put in the private, I told you yesterday, because you want your ALB to be public facing. So ALB have to put in the public subnet where we have an internet gateway. So I have to put into public subnet. Okay, even though if you put in private, they give this warning here. Okay, you have to put into public subnet. Okay, and your ALB is a kind of server program or kind of device. So we require IP address. Why? Because when the client hit to the DNS name, the DNS will convert into this IP address or this IP address. So they require some IP address. So this IP address is being assigned automatically by that is a public IP, obviously, that then only the client can connect. So this public IP is automatically assigned by AWS. Okay, so you have no control. They assigned by AWS. It means there's a possibility in the future after some time the IP might change. Okay, so technically there's no harm as such in some cases. Okay, because client will always connect to DNS name. So let's say IP is 100 right now, IP is 200, it's a public IP. In the future IP changes to 110 and 210 or 211, doesn't matter. Okay, AWS behind the scene update the DNS report. The DNS name is one going to change. Name would be always same. So client will connect to this DNS name and DNS name will automatically convert to the new IP address. So you don't have to worry about this. But in some cases, okay, changing the IP address pose some issues. Okay, maybe especially client side, you have some kind of firewall. Okay, and if IP changing of your server or load balancers, okay, then firewall might block the remaining IPs. Okay, so what I mean by this, I will explain this concept a little bit more in detail. Okay, I'm skipping this part, but this is the one problem we have in ALB, and that is the reason we use NLB, network load balancer, together. In network load balancer, we have a way to, we can give this IP address of my network load balancer. This is the next topic. Okay, that is make it permanent. So why we need permanent, I will have a discussion on this. We'll discuss in some time. But I just want to tell you here, they give the public IP to you as an AWS, so there is a possibility they will change. Technically, client will connect because they use the name, but they can change. This changing might create some issue in some kind of client-side security, firewall blocking. Okay. Now this is the security group. Okay, so firewall rule that control the traffic to your load balancer. So our security group you want to add. So let me use a security group that allow all traffic. Let me use web SSH. Okay, because my load balancer right now is working on some port number. So let me allow this one, or maybe allow all if you have. So what I want to use, let me use this one. Don't default. Let me create a new. I don't know what I have. So let me create a new. Make it simple. Okay, so let's say my application load balancer security group. Allow all. Okay, it's a part of my VPC. Same VPC, and add rule. I'm allowing for all traffic right now. You can change, but let me allow for all. So this is my ALB load balancers. So security groups. ALB description. Okay. So let me refresh, and this come up. My ALB doesn't come up. Why? Because I would like to create in a VPC called 3060. I think I create in the wrong VPC. Security group should be part of C or same VPC. Okay. So I have to, and we have to create the security group. Okay, one more time, my ALB allow ALB description, and you have to create in a security group of your VPC. Input rule is all traffic. So when this is the security group for your ALB load balancer. Okay, so anybody come to ALB, this is a security group we have. Allow all, right? That's what. So we go default, allow all, I'm going to use. Now guys, this is what the rule I was talking about, listener and the routing. Okay, listener and the routing. So what this line means? This line means, okay, anybody who come to your ALB load balancer, anybody come, obviously client will come. Okay, on a protocol called HTTP, it is written here. On ALB port number 80 is written here. If you want to change, you can change also. Okay, so ALB will send this traffic or route this traffic. This called routing. ALB will listen on this port number, and protocol number is called listener. This is what we write here. This is a listener we have. But after they listen, they will route this traffic. This is called routing. Where this is the action we have, where they will route. Okay, so they will route this traffic to target group 1, target group 2, and much more. Okay. So in our case, you can create target group directly from here also, but we already created, so you don't have to create again. So they send this traffic to whatever action would be. These are targets we have. Okay. So let's say I want they will send to the target group called search. So search will be the target group you will have. Okay. Do you want to add more listener? Okay. So like this is final called rule. One rule we have created. You want to add more listener. So you can add more. I don't want this right now. Okay. Listener, I want only one. For example, in google.com, you have one listener only, right? This is the name, protocol HTTP, and the port number is plus 80 or 443 they are using. We have this. Listener is one only, but based upon the path, they are changing the target group or changing the app name. Okay, so that's what I wanted. So listener, I want only one. Sorry, I only want. So there's no meaning to get two listeners. But in one listener, when anybody come on this port, I want to create a multiple rules. So this is the one rule we created, and this rule is called default action rule. Default means anybody come on this IP and port number, for example, Google. If nobody type anything, so default rule will what? They connect to the search. Okay. Actual name and the path is search only, right? This is actual path. But if nobody type this path, then default will be, or default action would be what? Or this called home page will be what? Right? Is search. So that's what they're talking about here. Default would be this one. Okay, but we add more. So extra service and global accelerator, we'll discuss what is global accelerator in the future classes, but this is the summary we have. I don't think so any change we have to do more here. No. Okay, and that's all. Right now, your application load balancer has been created. It is taking some time on registering your initial instances in this particular target group. Right now, I create only one target group, but we can create more by getting a rule, how I show you. Okay, and then you'll be ready. Okay, so let me view our load balancer. So this is what the reference is created. It's been provisioning. Means that it's because they are kind of one kind of program only or one kind of instance only. So they are provisioning. Okay, and sometimes they will create. But right now, if you see here, this load balancer has been given a DNS name, the same way I showed you yesterday. Right now, if you try to connect with this name, nothing will work as such because they are still launching behind the scene. Okay. By the meantime, they're launching. Let's see something. So current detail of this load balancer is application load balancer, internet facing, running in this VPC, because I'm putting this ALB in a two AZs, means by default they are working as a high availability, right? And security group, this is what added. Okay, so this is security group for my ALB, but we can restrict because this ALB running on port number 80. So I can say anybody come on port number 80. That's what I allow. Rather than you allow all, you can change, and these are some other details. Now, if you see here, the main thing of this particular ALB is the listeners. Okay, this ALB is only listen on port number 80. Means this port is available for HTTP. And by default rule is we will we will forward to this target group. This is the by default rule we have. Okay, but I want to create more rules. Okay, the rule will be the way I show you already. If somebody comments /mail, then different target group go. Somebody comments /search, they move to different target group. That's what I want to create. But before this, let's first they become active. Now become active, right? And then they go to description. They are active, but behind the scene they connected to this target group. So if I open this particular target group, this is called or what are connected stars or something like this. So this target group, okay, if I see, let me close this target group. If I open this target group, guys, last time you can see the message was unused to, but now it is too healthy. Okay, because this target group is used by this application load balancers. And this because in this target group we have two targets. Now both the target is healthy because we check the health check, everything is working fine. In the future, this target group, if they think there's a lot of load coming up, they can add a more instance. They can add more with register targets, or they can also remove. That's called de-register. So that can be done. Adding more is called scale out. Removing something is in your target group or in your load balancers is called scale in. Okay, so we can do scale out and scale in as per your demand and requirement. I am doing it manually here, but when I start the next topic, maybe tomorrow class, then auto scaling concept will automatically do by checking the real time traffic and other decisions. Okay, so this is what we have now. If I go back to this ALB, and if you try to hit this particular URL, okay, you will see I connect to this URL, and now we can see this message. Okay, why this message come up? Because right now, okay, let's say this is the google.com. Okay, and in the google.com, when you type /, okay, so they will connect to the by default application that's in the Google, that's called search. Same way it is connected to my by default application, and by default application is this one. And the by default application, whatever the home page they have, they connect home page. By chance in this application, okay, I have two different pages that I created. One yesterday, guys, by chance, yes, / and today I created /search. Okay, but because my client is typing /, so same / go to my backend, and the backend, all right, if you have any program running /, they will connect to the /. That's what this message was coming from the instance what I created yesterday. But let's search. Okay, you see, guys, they are trying to find and search, and now they are connected to I am a Google search. Okay, but if you also want same data will come in /, so that is actually we can get a rule, or technically it may be done by the developer or the instances who is managing. So in the server they can write and become some here or here, so by the same data. So that can also possible. The multiple way to do it. But yeah, it is working. That's what I'm trying to tell you. It is working here. So anybody come to /search, like a google.com, this name is google.com /search, they head to this instance, or I hit enter, they move to this one. If I hit enter, A, B, perfectly, guys, they're working. Fantastically, it's working. Okay, so it means anybody come on my application load balancer, they balance the load, but before they balance the load, they will first send your data to respective target group, and then they do by doing the balancing between the instances. It will be mostly like what we have done yesterday. Okay, but the interesting fact you will find when we test /mail, then it will be more interesting. Okay, if I test /mail, in this case, right now, what is happening? What will happen? It will say not found. Why? Because they are finding /mail again in the same target group. Because right now I have only one rule, that's called default rule. Every top traffic is going to the same target group, and in the same instant they're looking for /mail folder or mail program that is not exist. That was the error is coming. Okay, even though in this first target group, if you create a folder for /mail and put the index.html page, it will open. Okay, it will work, but that's what I don't want here. I want Anybody type /mail, it will go to different set of servers, maybe a different team or different target groups. Okay. And for this, we have to create a rules. Okay. So how to get the rules? So for the rule, you have to go to your ALB in the listener. The default rule is always send to the traffic. Any traffic doesn't match, any rule doesn't match. For example, /mail is not matching, so they will send to your search target group. Okay. So default means any rule doesn't match, always send to default. And you get things, this is like a last gate of resort. Anything doesn't match, send here. Okay. But I want to create more rules. Okay, node listener, more rules. So there's option here, view and edit the rules. Okay, in your ALB only. ALB, this is the duty of the ALB to create the rules. So here I'm going to create more rules. And this is the default rule we have. Okay, and rule said anybody come on port number 80. If request otherwise not routed, it means in any of the cases the request doesn't match. Okay, they always send to this target group. 100% of it. Okay. But I want to create a more rule. So there's option guys in the top, let's go plus. If we add in the plus, okay, then here we can add a rule that's called insert. Okay. And then click on the insert, then this page come up. Okay. And in this page, we can write a condition if and then. If this traffic match, then do this. If somebody sends /email in the path, routing on the path or the route, then if this match, then send this to target group. This go if and. So if and then. Okay. And if you don't add any condition, by default all match. Okay. If you don't type any condition in the if, it means all the traffic should match, and where you want to send the traffic, then you can use in the then. But let me add a condition in the if these options we have. If the IP address of my client is this one, so we can also set it in this way. Okay, the one of the great example would be maybe you have some specific client or some Intel clients. Okay, and maybe some client based on some region or country, and you say if any clients come from this region or this country, there's some IP range in some countries, come from these IP, send this data to this website. Let's say IP is coming from India, then send this request to some app that is written in Hindi as a language. Then target group will be Hindi. Okay, and query string, what is query string? I told you already. So anybody send something in the query string, let's say Vimal, send to this target group. Or somebody send in the HTTP header method, send here. Okay, so almost whatever in HTTP header, source IP, path, header, grammar, method. Okay, you can check this. Okay, because this application load balancer, they have a capability to check the application header, like HTTP especially. And accordingly, they check this. In our case, I want to check the path. And path is if somebody types /mail, or maybe let me say slash also, /mail, or maybe let me write /mail. Somebody types /mail or slash after slash also, we have both have the different meaning. Okay. So anybody who typed this, and be more. Okay. In this case, okay, I want. If this is the case, match in the path, let's call it route. Okay, then my action would be I want to send to or redact to or to fix a response. So let me forward to a target group. Which one that we can choose? This both the target group we have created. So I will send to the target group called mail. Okay, group called mail. So that's what we can do. Even the one more powerful thing we can do here. Okay, this is very, very interesting concept. So even though guys, we are not in the DevOps track, Normally in the DevOps track, we discuss this kind of concept a lot. Okay. So now, normally what happens, guys, your applications keep on changing, multiple versions is keep on coming up. Okay. And what we do, let's say one version of my mail server running here in the target group number 1 of the mail, where my older version working with multiple computers are running here. Okay, everything working great. Okay, but let's say new version of my mail come up, so we can launch some more computers, okay, for the mail server with a newer version of mail app, and let me give target group number 2 for mail. But this newer version has no guarantee there might be some bug. So there's a multiple different strategy of the deployment. Okay, one of the strategy would be canary deployment. Canary means some of the traffic you can send here, not all. Maybe you can say 1% traffic you can send here, and remaining 99% you can send here. And based on the one traffic from public feedback, you can further plan to send all the 100% traffic here in the newer version. Okay, newer version. So that kind of level of planning also we can do here. So we can add one more target group. Let's say there's a target group mail 1, mail 2, and here we can write the distributions. One means 100% distribution, but we write, let's say 0.99. Okay, or it's actually number between some any number. Let's say this is a 99, and let's say this is 1. Okay, so out of 100, 99 plus 1 is 100. Out of 100, this is 99, this is 90%. So 1% traffic go here. Let's say in the mail version 1, let us say 1, and 99% will go to mail number 1, or maybe 2 version, the older one. Okay, so automatically anybody come to /mail or /mail/, okay, they will move to different target group, but 99% older one, this mature app already tested, and newer app just to check for further checking. So these are kind of concepts we use in DevOps world, deployment world, or SRE, or further strategy planning. We can do. I'm just giving this extra information. Normally in the DevOps track, if you go in advance, these are kind of concepts come a lot. Right now, I don't need this, but even though, guys, if you do this, that's what it will do automatically for you, but I don't require to do. Yeah. Okay. So this is what I create one rule. And if I come here, I want to send to this guy. Okay, this target group. Save. Okay. Similarly, I want to create one more rule. Even though by default everybody would go to /search, but it's not the good thing. Okay, search a different app altogether. So I would like to create one more rule. Okay, insert a rule here. Anybody who come in this path called /search, or maybe /search/. In this case, I want to send and forward to this guy to to my target Google search. Save. Okay, and any path that doesn't match, they will send to by default search only. This is what the Google has used behind the scene. So anybody type /search, they go to search. If anybody don't type anything, by let's say slash, they will by default go to search. Something like this they have done. Okay, so this is one point. Let me add one more rule. Somebody might also try to go to this path. Let's say this is the /login. Maybe, but it's not there. Okay, so in this case, somebody tried to just do /login, /authenticate. I want to give a fixed message. So without reading any of the target, you can send a fixed response with some response code also. What response code you want to send? Because for browser handle different response is different message. Okay, so let's say you want to send a reference 543 and say you are not allowed to go in contact to department, something like this. Plus text message, HTML message, right? What kind of message you want to send? That will be your choice. Okay, this also can be done. So like this, there's lots and lots of rule we can create, and rule guys again we read in the order. First, the rule is one. If this rule match, they will do this. Okay, then they don't go in the next line. But if this rule doesn't match, then check this. If it doesn't match, check this. If match, they will go here and do the things. Okay, if this rule doesn't match, then they go to last one. This is the default one. Okay, so this is how they work. Okay, so these are guys, this kind of rules, so you can create a lot. Okay, and multiple different conditions, and also you can write. Okay, total number of rule per application will say 100. These are conditions you can have. We have here in ALB. So this is guys the different rule we have created. Okay, and you can also write a rule in between also. If you think any rule you have to do before mail, you can do before also. The rule will check in the order 1, 2, 3. Any rule match first, then they don't go in the last line. So this rule is work for this ALB only for this listener. Okay, anybody come on the port number 80, then this rule match. Anybody come on different port number, we will have the different rules we can create, and we can use we can reordering the rule by this arrow also. We can remove the rule, all the things you can do. So let me go back now in this load balancer. Okay, now we have a one listener, and in this one listener, okay, we have a rules, and in this one listener, these are the rules we have. It's like if or else kind of if, else if kind of thing. Okay, now this level of power we have in ALB. That's what I think we understood now. Now anybody come to my /search, they can hit to my my search app, A and B working very much fantastically. It means they hit to the group number A, this one. But if anybody type /mail, okay, they hit to my mails here, mail number B A. So they hit to my mail programs here, working very much fantastic. Okay, if anybody type by chance they try to log in, you want to send some messages, there's no target group, but one custom message will go. Your HTML page you can also create there will go to them. But anybody type anything, okay, in this case they will say you are not found. But we can create some wildcard also there. Anybody type something, anything, you can create a wildcard. In this case, they will go to this page. Or anybody come to my home page, okay, they come to my search, because I make my search as a default. Okay, search and search whatever the home page you have, you can type. Okay, so this is the guys about the ALB. So almost all the main concept of the ALB I explained to you, and this is a very detailed plan rules we have created. Okay, and if you go to your target group also, now this mail target group guys is also been enabled. Okay, I don't know why it's not showing unused. Yeah, it's healthy. It's healthy, right? So that's all guys. So very, very powerful, practical, very useful, and very much usable for the real world. Almost everywhere we use this kind of load balancers. Okay, so that's all guys about application level load balancer. Now there's one more level load balancer, NLB and GLB, or gateway load balancer I can say. So in my next class, I will quickly cover this load balancer. After having this information, then remaining load balancer doesn't take much time. And there's some more basic concept we have here, sticky bit and something like this. We also cover tomorrow. Then we move to auto scaling groups, right? That's all for today. Any query if you have, you guys can ask me. So excellent session, sir. Thank you, Ankit, very much. So person you asking enabling DNS host name, auto signing IP. Actually, enabling DNS host name is required. If guys, if your enable DNS host name is not enabled in the VPC, then while what I say, launching the load balancer, they will fail. They might not work because load balancer have to assign DNS name to your load balancers. But in a VPC, if the DNS name uh, enable is not there in the VPC, it will fail. So please go and check in the VPC, does enable DNS is enabled or not. In my case, I already enabled while explaining the VPC, but go and check in the VPC for this. It is better Nginx. Actually, different. Somebody asking me, this is the cloud hosted solution, right? They might be using Nginx behind the scene. We never know, right? But Nginx or something like this, like HA proxy Nginx, that is a product that we will put in our own server to create our own load balancers. Same thing we can do with Nginx also. The only difference is these products we will create and or configure in our own setup, and we are going to manage ourselves. Manish, I will give some idea on SSL in load balancer in my next class. Nitu, VPN is not the part of, we have basic discussion of VPN in this training we'll do, like overview, but VPN is actually the part of security class. And so advanced security class, we will normally discuss the VPN there. But there's some basic overview I will definitely do in this class, SCS level. Okay. What is stickiness or group level stickiness? Mehul, in my next class tomorrow, when I explain you stickiness, I will explain you what is group level stickiness also. So आपकी तरह सर हम मैनेज कैसे ला सकते हैं? You will get such in, don't worry. Even